Okay, just some examples then on critical regions. So again, what we're going to be working out are the values, the critical values. So the first value that will lead us to rejecting H naught. And again, it's just a bit easier then really when you've got a critical region, because you know you don't have to work out the p-value every single time. You've done it once, you know whether you're going to be rejecting H naught or not. So this first one then, apparently 25% of men are colourblind. There we go. But it's believed that the condition is less widespread among a group of remote hill tribes. So apparently there's some hill tribes where they are less likely to be colourblind. An anthropologist plans to test this by sending field workers to visit villages in that area, and they will test 30 men in each village, and they'll be tested for colourblindness. Find the critical region for the test at a 5% significance level. So again, set this up as if it was just a standard hypothesis test. So again, apparently 25% of men are colourblind, and we want to check, is it actually less in this area? So what I'm going to be counting then are the number of colourblind men. And our N is 30. We'll be asking 30 men, or testing 30 men in each of these tribes. So I would expect them then, under normal conditions, under H naught, to have a distribution like that. And so I would expect, on average, a quarter of them, which is 7.5, so about 7 or 8 of them, 7.5. Sorry. About 7 or 8 of them to be colourblind each time on average. So I think it's going to be less, or apparently then is less widespread. So I'm assuming then now that I'm going to be less than my expected value, more extreme, but on the less kind of side. So maybe 6 is a bit too close, maybe. What if I try 5? So all I've got to do now then is just think, oh, what if 5 of them were colourblind? Well, what would I do then? I would work out the p-value. I would say, right, what's the probability then of getting my sample value, which is 5, or even more extreme, so even less? And again, tables, x is 5, n is 30, p is 0.25, and that comes out as 0.203. There's a 20% chance really of that happening. Yeah, it's quite likely. All right, fine. Not enough evidence to suggest that there's less of a percentage colourblind. Okay, so what if it was even less? What if it was even less? 4, maybe? What does that come out? That's 0.09. Ooh, that's close. 9% chance, but still not enough for me to start saying, yeah, strong evidence to suggest to reject H naught, and suggest that they are less likely to be, or is less widespread among this group, colourblindness. So again, even more extreme, even further away from what I'm expecting, but if only 3 or less of them are colourblind, well, that's a 0.0374. Right, so 3 would be the first value where it's less than 5%. So that is the value where I would start rejecting H naught. So my critical region, which is what the questions ask for, critical region, is x is less than or equal to 3. Remember, x is the number of colourblind men. If it's less than or equal to 3 out of 30, I would reject H naught. I would say strong evidence to reject H naught. Therefore, the condition is likely to be less widespread in this hill tribe. Okay, that's the first example. Now on to the second one. Manufacture a new type of seeding compost. Again, this is quite similar to the one that we've done before. He says that his new super compost has a higher germination rate. And for a particular variety of seeds sown in ordinary compost, the germination rate is 70%. So usually, on average, 70% of seeds germinate in regular compost. To test the manufacturer's claim, An experiment was conducted of which 20 seeds were sown, and the number X, so the test statistic, which is the number of germinated seeds, was counted. A. Oh yeah, hang on, I think I've changed this for the one I've sent to you, but that's meant to be greater than or equal to 17. There, greater than or equal to 17, be careful. Find the significance level of the decision rule that accepts the claim if it's greater than or equal to 17. So what they're saying there is, right, I've just decided that if 17 or more germinate out of 20, then yeah, I'm going to reject H0 and say, yeah, this is super compost. But what significance level is that? Is that, you know, unlikely? Is 17 out of 20 unlikely in regular compost if 70% germinate? I don't know. So again, set it up as if it was a standard H0 hypothesis test. So regular compost or super compost greater than 0.7. So this then is the number of seeds germinating. And that would have a binomial distribution because n is 20 and planting 20, and usually under regular conditions 70% germinate. So I would expect in regular compost 14 to germinate, 70% of 20. In this case, they've given us the rule. They've said, oh, what is the significance level of this? Well, remember, the significance level is the probability of your critical region. That's what it is. It's the probability where you start rejecting H0. Well, I start rejecting H0 apparently if X is greater than or equal to 17. That's what this decision rule tells me. So my p-value then of that, p-value of my critical region, is my significance level. 1 minus probability of X being less than or equal to 16, which is 0.1086. So it's about 10.86% significant level. Where did that 6 come from? I haven't even got that written down. I don't know if there's a 6 there. Sorry, there's an 8 there, definitely. Why did I put a 6 down? There's about a 10.8% chance that I get more than or equal to 17. So they've given us the decision rule, they've given us the critical region there, greater than or equal to 17. So what significance level are they working at? So instead of asking us to find the critical region based on a significance level, like in example 1, here they've given us just the decision rule. They haven't worked out the probability. They've just said, yeah, 17 or more, I'm going to say that's too unlikely. So really they're saying, yeah, if there's less than a 10% chance, if there's less than a 10% chance of something happening, then I'm going to start rejecting it. There we go. Part B then says, find the decision rule whose significance level is 0.05. So actually, if they wanted to be more stringent, more precise, and working at a 5% significance level instead of a 10% significance level, what would their decision rule be? So, part B, I know then a 17 wouldn't be enough. I want to get further away from 14. So I try 18, which is 1 minus the probability being less than or equal to 17. So if 18 seeds germinated, the probability of 18 or more seeds germinating is actually 3.55%. Yes, that would actually be enough at a 5% significance level to start rejecting H0. So my decision rule then would be something like this compost has a higher germination rate if 18 seeds or more germinate out of 20. So therefore they've said, what conclusion should be drawn if 18 of the seeds germinate? I would say that strong evidence, if 18 or more germinate, then there's strong evidence to suggest that that this compost has a higher germination rate. There you go. I'll stop this here just before it gets too long, and then I'll do example 3 on the last video.